Societal challenges such as poverty, corruption, job losses due to technology, climate change, extreme biases, education inequality, violence, and weak public health are complex challenges. These involve an interplay between many diverse components that include humans who have agency and machines that increasingly use artificial intelligence. Tackling this complexity requires us to find a way to solve these societal challenges at scale. That is, to solve complex system challenges. Many experts have said societal challenges can be tackled if we can eliminate learning inequality. In this short video, we will share with you one way to categorize complex systems, and we will describe an approach to tackle them. This work has been produced in collaboration with many individuals and organizations over the course of 10 years. That includes researchers, school districts, and non-profit organizations from around the world. Together, we have developed Gooru Navigator, a GPS for learning, to address the systemic complexity of learning. Today, we have over 7 million users in 27 countries across education, skills, and professional learning, all using Gooru Navigator and the navigated learning approach. Learning is foundational, whether we look at students in pre-K, school, higher education, apprenticeships, on-the-job training, professional development, skills training, or those who need to research to solve novel problems. Learning is not predetermined, which means we cannot simply deconstruct the process of learning into a series of smaller problems to solve and then combine them to create a solution. Learning, on the other hand, is complex. Learners are diverse with varying proficiency, interests, mindsets, local context in terms of their technology access, languages of instruction, curriculum standards, and abilities, giving each learner a unique starting point for their learning journeys. Learners are also surrounded by unique communities, and interactions with these communities enhance their knowledge, mindset, and citizenship. Learners interact with many resources that include digital resources, offline tasks, and team activities. And there are many stakeholders that in their own ways try to support the learner, such as instructors, leadership, parents in the case of young learners, researchers, and curriculum designers. When these diversities, the wide range of components, and the large network of stakeholders interact in complex ways, they come together to support the learners. Learning is therefore complex, where outcomes are different from the sum of its parts. This process of learning is complex. In this video, we will first look at the characteristics of a complex system, then we'll look at the complexity surrounding learning, and finish off by describing the navigated learning approach which can be used to tackle this complexity. Let's look at some of the key characteristics of complex systems. First, information within complex systems is distributed. There is no single source of complete information. Instead, the information is distributed across all components. Second, complex causality, which means there is not a simple cause that produces each effect. In complex systems, every component's behavior cannot be modeled as a closed-form function of few variables. Every component has many inputs and many outputs, and the components that represent people have agency. That is, the output for the very same set of inputs can be different every single time. Third, non-linearity. Here, big initiatives may not have any impact due to the negative feedback loops. And small changes can cause big effects due to positive feedback loops that amplify the impact of the small changes. Fourth, resilience. Complex systems, when perturbed, move to restore equilibrium. As a result, complex systems that contribute to societal challenges, such as poverty, weak public health, and education inequality, become difficult to change. Finally, emergence. Complex systems have many interactive components of people and machines. The learning experience of the learner is emergent based on the interactions among many of these components. As a result, in complex systems, replication is not scaling. Let's quickly look at the differences between complicated systems and complex systems. One defining characteristic of complicated systems that have predetermined solutions is that we can scale by replication. For example, if Google Maps works for one user, then it similarly works for everyone else. However, within complex systems, replication is not scaling. Humans and AI are participants in a complex causality network that support the learner. Each unique solution for every learner is emergent from all their combined actions. In complex systems, replication is not scaling, we scale with emergence. Now, let's look at the complexity surrounding learning. A comprehensive approach to learning has to be equitable, so every learner, irrespective of their proficiency and preferences, can get to their learning goals. Enable lifelong learning so that we can support the learner throughout their learning journey, from K-12 to college to skills training and professional learning. It should also support data ownership by learners or their institutions, so we do not silo the learner's data across systems and tools. It should provide total choice, so learners have the flexibility on why, what, how, and where they learn. It should implement interoperability of tools and resources, so it is future-proofed from the evolving changes in tools. It should also enable learning with all types of digital resources that include offline tasks, group projects, and many more. It must work in low-technology environments where connectivity may be intermittent. And it must be community-driven and integrate research and practice so we can accelerate outcomes for all. Lastly, let's talk about the navigated learning approach, which can tackle this complexity. We start by aggregating data from learning activities. These learning activities can be from curriculum-based formal education and training, job tasks, or based on interests from life events that surround us. Every learning activity is associated with a point on a structured learning space that consists of a progression of competencies. The navigated learning approach captures data after every learning activity. These activities could include digital content, offline tasks, group activities, lectures, podcasts, conferences, and so many more. Data from digital activities are captured directly from a variety of systems. Offline tasks, such as projects, can be rubric graded by the learner, their peer, or their instructors. Every data element is associated with a learning activity, competency, and the learner. With this aggregated data, we can accurately locate the learner. Activity stream data pertaining to the wide variety of learning, such as watching a video, answering a friend's question, sharing something with colleagues, and accepting or rejecting suggestions for additional learning. These can then be processed by using a variety of algebraic and AI techniques to update the understanding we have of the learner. A learner's knowledge includes measures such as progress, proficiency, preference, and portfolio. A learner's mindset includes measures like grit, perseverance, motivation, and self-confidence. A learner's citizenship includes measures such as community, authority, and reputation. Learners' behavior includes measures like commitment and engagement. And their context includes measures like emotion and interest. With an accurate understanding of the learner, we can now curate appropriate learning activities. Activity stream data pertaining to learning resources can be processed using a variety of algebraic and AI techniques to curate the learning resources with content metadata such as transcript, summary, competency alignment, and Lexile level, and efficacy metadata such as relevance, engagement, and outcomes. This is then used to mediate pathways. With an understanding of the learner and a catalog of curated learning activities, suggestions can be made using AI to every stakeholder. Learners can get adaptive suggestions for learning activities. Instructors can get suggestions of personalized interventions to support the learner. Leadership can get real-time data about various cohorts. And parents can get insights on where their children are excelling or struggling. Stakeholders leverage their expertise and coordinate their support of the learner, which in turn updates the data we have on the learner. The navigated learning approach, built on open standards and interoperability, enables experts to coordinate and optimize interventions for each unique learner and their community of supporting stakeholders. It is this that enables unique solutions to emerge and systemic change to occur at scale. Learn more at Gooru.org.